Hello, this video is about the properties of kites and how to find the area of a kite. A kite is a quadrilateral, has four sides, 1, 2, 3, 4, not a parallelogram, but a quadrilateral that has two pairs of opposite sides that are non-congruent. Okay, these opposite sides are not congruent. But it has two pairs of consecutive sides that are congruent. So this side would be congruent to the other side here, but these opposite are not congruent, but the two consecutive pairs are congruent. There are three special properties for a kite. All right, so one pair of opposite angles are congruent, and these are the ones that are like on the sides. Between the non-congruent sides, okay? That's the only pair of angles that are congruent, the side-to-side angles, okay? Another property is that the diagonals are perpendicular. So when we draw in the diagonals, they make a right angle. Okay, that diagonals are perpendicular. A third property is the top to tail diagonal bisects the top and tail angles and the other diagonal. Okay, so this one diagonal right here, it bisects this angle here. Let's say this is our top, and this is our tail of the kite. Okay, so those angles are bisected, and the other diagonal is also bisected by that top to tail diagonal. I want you to make sure to notice that the side angles are not bisected. So these angles here are not bisected. And the top to tail diagonal is not bisected, okay? So see how I have a long part and a short part? This is long and that's short. And then these two angles are not the same. Okay, so let's do a couple of examples based on these properties. All right, in example number 1, kite ABCD. Remember, we go around the quadrilateral when we name them. ABCD, measure of angle DAB is 54, and the measure of angle CDF is 52. Find each measure. Okay, so what we know is that CDF is 52, and I know that DAB is 54. All right, so we want to find the rest of the angles. Well, I also know that all four of these angles are right angles, okay? And that all the angles are going to add up to 360 because it's a four-sided figure. So this angle here, this 54 divided by 2 makes 227-degree angles because this one is bisected. Okay. So I also know this is 90, so I can figure out what this angle is on this triangle. And so that would be 180, or 27. I'll call this X. And remember, this is going to be X also. So 180 equals X plus 27 plus 90. And so if I combine like terms and subtract, I end up getting X is 67. So 67 degrees for this one. and this one. Okay, this angle over here is also 52, and one of the ways I know that is since these two sides are equal, these are the base angles of an isosceles triangle. And so now I just need to figure out what this angle is here, and so I have another triangle that we'll call this Y. So I have 180 equals 52 plus 90 plus Y. And so when I combine like terms, I end up that Y is equal to 38. So that means that both of these angles are 38s. And we've got all of our angles. I wrote 67 here. It's supposed to be a 63. So that is a mistake. Fix that. All right. For the next example, Erin is making a kite based on the pattern below. She wants to add a trim around the border. How much trim does Erin need to cover the edges of the kite? Okay, well, we know that we want the perimeter because we're looking for the edges of the kite, so that would be the perimeter. Okay, so if we know this, we know that the head to tail is going to bisect the other diagonal, and since it's 64, that makes each one of these 32s. Okay, and this is a 13. So we know we have right angles. That means we're going to do the Pythagorean Theorem. So I'm looking for the hypotenuse. We'll call this one C, and this will be also C. C squared is going to be equal to 52 squared plus 32 squared. So I've got my A and my B here. So the square root of 52 squared plus 32 squared in the calculator comes up to be the square root of 3,728, which is approximately 61.057. Okay, so that's that side and this side. So we have two of those. So my trim, we'll come to that in a minute. Now I need to find this side. We'll do this in another color so we can kind of pay attention to what is happening here. We'll do this side in blue. So these two sides are blue, but we're going to look at this right triangle. And so my hypotenuse is C. So C squared equals 32 squared plus 13 squared, this little segment here. And so the square root of 32 squared plus 13 squared is the square root of 1193, or approximately 34.540. All right, so my trim is equal to 2 times 34.540 plus 2 times 61.057. And so we get approximately 248.137 inches of trim. You try the next one, and then I'll do the answers in double time to see if you got them right. Put it on pause and see if you get it. Now let's talk about the area. Okay, this first example, we're going to find the area. This was the example from example 2, and we're going to find the area of this kite. Okay, so basically the area is from 2 triangles. We've got this triangle here, and we have this triangle here. and they are congruent triangles. So we have two triangles. Okay, so we have 2 times 1/2, 65, because this 13 plus 52 is 65, times the height, which is 32, because that was just half of the whole thing. And that's 1,040. And so we have 2 of those, and so our area is 2,080 inches squared. So we can do it that way because we do have 2 congruent triangles for each example. So this would be 8 and 8, and then I would have 2 times 1/2 base times height. So 2 times 1/2, 8, or my height, my base in this case, because I'm using the tail to top to tail, diagonal, and then my height is half of the other one, so that would be 8. And I get 106. So this is half of 20 is 10. 10 times 8 is 80 times 2. So the area here is 160 units squared. So on this one, again, we have 2 triangles, and we know that our height on this one is half of 19, which is 9.5. And so 2 triangles I have 1/2, 38, times 9.5. 2 times 180.5, or 361 units squared, because they didn't give us units. All right, so just like we can do this, we can also use that formula and base it on the same way that we do a rhombus by doing 1/2 diagonal 1 times diagonal 2. All right, so we're going to just do it the same way. Find the area of the following kites. The area is 1/2 the 2 diagonals, so 6 plus 6 is 12, and 10 plus 2 is also 12. So 144 divided by 2 is 72 units squared. All right, let's look at this one. This one doesn't give us the second diagonal, but we do have the Pythagorean Theorem that we can use because of this right triangle. So because we're looking for a leg, so this is our, we have our 13 squared, our c squared, equals a squared plus b squared. 13 squared equals 12 squared plus b squared. So we'll call this our b. So we do the math, and we get, so the square root of 25 is 5. So this is a 5, which makes this whole thing 10. All right, so we're going to do the area is equal to 12 plus 8, which is 20, times 10. So half of 20 is 10, times 10 is 100. And again, we don't have units, so let's just practice writing it on there. In the last one, I have another couple more. Find the area or company logo of 3 congruent kites to be embroidered on their staff polos. What is the total area of the logo? So we have 3 kites. Okay, so one kite we know goes from here to here, and that would be 10 because it's halfway in the middle. And then the other diagonal is 6.5. So one kite is, the area is 1/2 10 times 6.5. So that is 65 divided by 2, or 32.5 centimeters squared. And so we're going to take that and multiply it by 3, and we get 97.5 centimeters squared is the total area of the logo. All right, and our last one. We know the area in this one. We get to work backwards. So if the area is 80, so the area is 1/2 D1, D2. So 80 is 1/2. We have one of our diagonals is 10, 5 plus 5. So we can figure out what our other diagonal is 12 plus something, right? Okay, so we're figuring out what x is. So let's figure out let's call the whole thing diagonal 2, and we'll solve for this. So here we get a 5, D2, 80 equals 5 times D2, divide by 5, and we get 16. Well, we already know that this part is 12, so 16 minus 12 is 4. So 4 is equal to x. And that's it for the kites.